So I hope you can see my screen as well. Okay. This is question number. We're just going to have a discussion on this. This is question number 3 in your CIA 2, right? The first question is about DNA, DNA binding proteins. How would you do? One, there are some in vitro methods. I will just go to okay. For protein interacting with DNA, there are protein DNA interactions, right? That is the techniques that can be used for it. There are at least techniques can be in vitro. I actually had a question, very specific, right? I thought I will ask you, give, explain one in vitro method and one in vivo method. After that, I modified it and just gave it as explain any technique that can be that can determine or if there is a protein can interact with DNA or not. In vitro methods, we learned two of them. One of it is gel shift assay or enzyme mobility shift assay, and the other one we learned was DNA's footprinting. Right, something like that. If we in EMSA, the electrophoretic mobility of DNA with and without protein will be different. The one with the protein bound to it will travel slower compared to the free DNA. That's the simple basis of it. For DNA's footprinting, we would have done with radio labeling. Of course, we should have spoken about radio labeling. In many of the answers, they did not mention if there is any requirement for radio labeling. Many people did not mention those things. So when you're writing, please give the specific details. If there is end labeling, if there is random labeling, and if labeling is done, how is it done? I am not looking for long essay type answers. All I am looking is a flow chart describing, say, this is what we take the DNA, we do some labeling, and how you do it is notes here. You just write the flow chart here and give important names of the reactions or enzymes, molecules, substrates in this on this side here. That makes an answer. You are demonstrating your the best possible understanding you have in an easy way for others to understand. We also had DNS footprinting, where we would have run the gel with naked DNA with chemical degradation. We could have done with protein. We could have used DNAs to have. So the region which is not which one, the DNA would normally form bands like this if it is cleaved by DNAs, and the region where there is no band, that is the place protected by the protein that we are added. So that is another technique. In vivo method, we have learned about yeast-1 hybrid system. That is, I think some people have done it, written it well. When you write about this, you should mention about what is that one hybrid mean, right? Many of you have done. There are few here and there who didn't mention that, so I'm just bringing it. Some of the answers are very elaborate, and some people have given more than one technique, and that's very nice. Well done, all those people. So the second one is about lambda zap. Even now, I wouldn't want to speak about it much because I gave you as an assignment for self-study. You had all the requirements to read and find the literature and read about it. I hope. Well, I'm just remember that you have to do it well. So it has multiple advantages. We should try to know what are those multiple advantages. You can circularize, you can make a single stranded one. You can use it for probe expression. Many things are there. You can use it as a vector, lambda phage vector. You can use it as a plasmid vector also. So I would want you to look at this and try to understand how it is constructed. And please, again, I would suggest, many people actually don't know it yet, how it is done. And I would suggest that you try to know it again. What is the significance of F1 origin? What is meant by a phage mid? There are many questions that you have to, when you study this, the lambda phage thoroughly, we will understand many things. What is C1857? What is meant by it? Why is it there? First thing is, you should know, you should have it, have the whole structure of lambda zap, and try to learn about why is it terminate here, what is it, what is an initiator, and why do we have C1857? What is C1 actually? Right? You must have learned about lambda phage in your molecular genetics or molecular biology paper. I would appreciate if you um, can go and look at what is C1 we know. What is C1857? I might give this question again in CA3 also. Okay. And so please try to read everything very well. There is a call E1 here. Why is there a call E1? Right? And why is there ampicillin resistance gene? Where is it located? So there are many things that you have to still learn about lambda zap. Please read about it. We should be able to be self-sufficient. If you followed the course enough, you should be able to understand all the literature. So this is us, and here is the material. We, through this course, we try to provide you all the requirements to be able to find and understand the material. Then there is only one obstacle, that is, again, you, right? Somehow motivate yourselves and try to understand the material. I would be more than happy if you did not understand something of it specifically after you put in efforts, and then please ask me a question, then I would try to answer. So this assignment, the exercise is for two things whenever we give self-study assignment. The first thing is to make you do it the by study by yourselves. I would like to use this DIY, right? Everybody, we all should become very competent with do it yourself. Everything, material is there, we have access to the material, we have devices to go and read, we know English, there are a lot of materials, fantastic lectures are there on all the technologies that we are discussing here, and many more also. All we need is to become self-sufficient and become confident in doing it yourselves, right? In the remaining courses, I think I will also, remaining parts, we have next generation sequencing, the basics of it. We will just discuss a little bit of it. But yes, I would also share some of the videos from the internet that I follow. You may also follow them and try to watch them. All it takes is your motivation to be there. The next one is about CRISPR, CRISPR-Cas, which I intend to start in the next slide, next classes, CRISPR and NGS. If you had prior preparation, a little bit of it, it'll be very nice for all of us. We'll gain more from the classes. Okay, I have a question first. Have you learned about NGS somewhere? Please quickly somebody answer. Next generation
Yes,
sequencing or whole genome. Yes, please. Parvati, go ahead.
yes, we have learnt it in bioinformatics.
Is it compulsory for everybody? Yes, bioinformatics is compulsory for all, right? Or is it an elective?
It was a compulsory course for the biotech people, sir.
Okay, okay. So may I know what all you learned so that I can customize it? You can't recollect, that's all right too. If you can recollect, tell me.
Illumina sequencing, sir. Ion torrent.
Okay, Illumina. Okay, then we'll have a repeat of it. I'm also going to speak Illumina only, a little bit details probably. I want to know how many classes you learned it. Any idea? I want to know the depth that you learned with.
So we looked into the ways in which it could be sequenced, the principle behind it, and how it works.
Okay. So in that case, we'll also have very similar thing here too. We'll only have basics actually, but still, I think it will be useful for all of us. And I also want to know: have you learned anything about CRISPR-Cas before in any of the courses? Anybody? Biotech? Yes, please.
We have studied it in genetic engineering, sir.
I had an
Okay.
genetic engineering course, sir.
Okay, good. How much did you learn of it?
So the principle
Um,
behind it, how it is inspired,
okay.
and then
Okay.
the application.
Yes. Yes. Do you have any material on that?
We have a few papers that we referred to, sir.
Okay. Okay. So just email me. I'll just have a look at it. Meanwhile, I will post some of my videos that I discussed last year. You can also watch that, and then you will be well prepared to understand. Okay, we are coming towards the end of the semester, so I want these two are NGS and CRISPR-Cas. These two are the hottest topics, and I guess many of you would be talking about them when somebody asks you about a project proposal or in interviews. To make the best of it, it's better that we prepare and come to the class so we can have a discussion as well. Okay, please try to do that. I'll try to post them, but there are also fantastic videos on YouTube which you can watch. Okay, coming to the last question. This is the question we had, and many people had many different types of answers, and maybe that's why I'm planning to discuss this now. P1 is homozygous, and we said in the question already said that P1 is normal. Okay, I want your participation. This is not for me, and this is about trying to figure out the answer together. So about P2, what does Southern Blot say, and what does Northern Blot say, and what does Western Blot say? Yes. So we'll call these alleles X1, X1. Okay. The P1 is homozygous. So if you see, this is P1 allele likely, because you are seeing the RNA as well, and you're seeing protein as well. So it must be having at least X1, okay, P2, and there is another allele because of which you have a shorter fragment here, and that means so we'll just call that X2. And it shows Southern Blot also says that it is a shorter fragment. It doesn't say if it is deletion or not. If it is shorter fragment, the reasons for being for having shorter fragment could be deletion, or uh, it could be formation of a restriction site, right? I hope you agree with that, because of a single nucleotide polymorphism, a restriction site has come. And in Southern blotting, the procedure is we take the genomic DNA, we do restriction digestion, electrophoresis, blotting, and then we get the result for Southern blotting. So the formation of a new restriction site may also have caused the shorter fragment. What may also cause, what if there was an insertion? Say, for example, there is a DNA, and this is the restriction site, and this is another restriction site. There happens to be an insertion. I will just draw this here. This is the restriction site. Say from this is the I'll put it as this. This is the insertion of some DNA. And then we had another restriction site that was somewhere here. Okay. And because of this insertion, and within that insertion, if there was a restriction site, and the probe is binding to this end, then it will give a smaller fragment too, isn't it? So we cannot say if it is deletion, we cannot confirm. These are all the possible ideas. It could be an insertion giving a new restriction site. That is also a possibility. Okay, what does the northern blot tell? It tells that there is an increase um, in the size of the mRNA, right? This is for X2. There is an increase in the size of mRNA, which could be for multiple reasons. Again, it could be multiple reasons, right? It could be an insertion, because when we say there is a when we say that there is increase in mRNA size, what we mean is that somehow there is a, this is the promoter. We had a gene, and it used to produce mRNA of this length, but now for some reason, for some reason there is a longer because of mutation, there is a longer mRNA. What could result in longer mRNA? For mRNA, the size of mRNA is determined by the transcriptional start site and the terminator. We also need a terminator. If there is no terminator, RNA polymerase would have will keep on going that way. So what is it? Of course, promoter, this element is not affected. That is fine. It could also be that there might have been an insertion of a large fragment here, because of which the size of mRNA is there. It could also be that the loss of the terminator sequence immediately downstream of the gene may result in a longer transcript, right? So in the conditions, we can say, we will say insertion is one possibility, and loss of terminator is another possibility. From this case, and anyway, in this too, if I want to say, you can put it as inversion also. I didn't mention any of these are possibilities when you talk about with perspective on southern blotting alone. When you use northern blotting, loss of terminator is a large sequence usually. It's not 3 or 4 bases. It's usually, it can be some tens of bases, or even larger if it is in eukaryotes. And so if it is deleted, it could reflect in the southern blot. I'm saying, please mark my words, I'm saying could. I'm not saying, I'm not assuring that that is what will happen. So insertion is one possibility. Here is insertion of a sequence, and that is why we are seeing a larger fragment, and which could be because of an insertion. Okay, but we are not finalizing. But this is the thought process I would want you to present when you're writing an answer for such an analytical one. There is no conclusive answer. It is only the depth with which and the breadth with which you think of all the possibilities is the answer for this question. So let's move and look at the Western blot. In Western blot, there is no protein product. So one protein product is there, which is likely the protein product that is depicted here. Sorry, why I put tick mark? Okay. Protein product is from here because we are comparing it with P1. So one allele is there, so we have half the amount of that product approximately. Now we have this product from X2 allele, and we don't see any protein product. We're not seeing any protein product. And if we are not seeing a protein product, which would mean that the antibodies that we have are not binding to the protein. or the protein is not produced. Not produced is one possibility, or the antibody that we have is not recognizing. When will it not recognize? When there is a frame shift. So there are two possibilities in this case. One of it is the protein is not produced, and the other one is a frame shift mutation. Usually, what we have indications from southern blot and northern blot is it is likely a large scale insertion. Okay, that's why we see a fragment. I'm saying likely again. Okay, we'll have to do sequencing to really figure out what has happened. But this course is about thinking. This course is not about the technology, right? It is about our ability to think and use the tools properly. So the most likely thing is that the protein is not produced. Okay, if there is a gene like this and you have promoter, and within this region we have a large scale, some protein has some gene DNA has inserted the gene, it's likely to produce a longer mRNA. It may produce a protein, or may not produce a protein at all. It depends on where the where the insertion has happened. If it happened near the ribosome binding site or within the start codon, right, then translation is going to be affected. So there is a possibility that the protein is not produced. Could be because any of these reasons. And in my view, I would tend to go based on probabilities of what happens to the genome. I would like to go with insertions at this case. It is certainly not a deletion. Mostly it's unlikely a deletion. You can also counter argue this way. What if it was a large scale deletion on this side, right? If it is a deletion of the terminator and other regions, then that is why you're seeing a fragment that is lost here. You can also say that because the terminator is lost, you might have a longer mRNA, and that's why we are seeing this longer mRNA. And maybe the deletion happened quite a lot. Say, for example, a protein, I'm putting it as in a linear stage, amino acid, N-terminal amino acid, and you have several amino acids and residues, and then C-terminus. Of course, the protein will be folded. Just for illustration purpose, I'm keeping it open. When we have an antibody, monoclonal antibody against a protein, it usually recognizes three-dimensional epitope like this somewhere, okay, which is made of different residues at different places. Say, for example, if this monoclonal antibody were recognizing some protein, some residues or epitopes that are in the C-terminus, and because of this deletion, if I said there is a deletion here, okay, and the gene is the antibody that we have is not going to recognize there, then we can argue that it is because of a deletion as well. So when you're writing answers, I would want to see how much of biology you understood. How much are you thinking about the whole of biology? Right? Are you looking at all the possibilities? If you know all the possibilities, I'm sure you will be able to figure out anything in biology. Let's look at 3. In 3, it must be there is similar, you have a band here, which is corresponding to that of P2, or we are calling it as X2 allele. So we'll call it X2 because we have one X2. This is corresponding, and I shouldn't just take it as S2, X2 immediately. I should have also compared with that of the northern blot. What is it? Is it X2 or not? They both are similar. So it is X2. And even in western blot, we don't see a band. So that those are properties similar to that of X2. But then there is a different one. The different one is that there is another allele here, and that we can call it as X3. We are trying to talk about what is the X3 mutation. Same logics what we have discussed here. That is how we are supposed to think. It has increased fragment size, which could be an insertion, which could be a loss of a restriction site, right? It could be a deletion because of which the restriction site is also lost, right? I hope you understood that part. Say, for example, this is the DNA, and we have these are the restriction sites, and there is one somewhere here. If we happen to have lost this region, this would have been, say, 3 kb, just for illustration, and this is some 4 kb, the total of it, and we lost some 1 kb here, and 1 kb including the restriction site that we have here. Then we will be left with, say, 2 kb and 4 kb, which is a 6 kb fragment, a larger fragment, right? It is a deletion, but it is reflecting as a larger fragment in southern blotting. And what is its corresponding northern blotting result? We see that there is a smaller protein, mRNA. So whether you want to call it as deletion or insertion, it again will depend on multiple factors. What you can see though is that there is a protein is smaller in size, right? From northern blotting, it could be any of these, southern blotting. From northern blotting, it could be small because of deletion, and it could be because of it could be many other reasons too. But mRNA is deleted. mRNA is small, which is most likely a deletion. Okay, it's not like a new terminator will form all of a sudden downstream within middle of the gene. That's not a possibility. Say if this is the gene and we are saying this is a terminator, we don't expect a terminator to form here all of a sudden because it's a bigger one. Okay, but you can always argue differently as well. We take in a large fragment which is having a terminator, it got inserted, because of which you are seeing truncated mRNA. That can be an argument always. And then we see the protein as well. Certainly we see a smaller fragment size, a smaller protein. It is detected by the antibodies, it is small, and so we will argue that what we can see based on the probabilities that would happen in the nature, the kinds of mutations that may happen, we can assume that there happened to be a deletion of something here, because of which a smaller mRNA is produced, a smaller open reading frame, because of which a smaller protein is produced, and that is what is shown here. Okay, if you have any questions or arguments with this question, I would want you to please bring me up. I would also encourage you to to discuss if you think there are more ways of seeing the data. My objective of this particular exercise is that when we are trying to deduce an answer, it's always important to be open about everything, open about all the possibilities. You are trying to look at all the possibilities, and then we are going to pick something that is of most probable one. If we want to have conclusive evidence and conclusively, if you want to speak, we will have to go with sequencing. But if we had other indications and some other information, more information, then you can probably use this much to know what it is, what is happening. Okay. As anybody wants to take or discuss anything differently about this question? You can also argue if you wrote something different and you think I didn't award marks for it, you can also argue here. This discussion should be there so that we will be able to address and we all can learn from each other.
So this is just an alternative thought.
Yes, go ahead.
So regarding the Western blot data for P3, the molecular weight of the protein is significantly less when compared to the other two. So my approach was like, what if the mRNA is like, what if there is a missense mutation, wherein there is a
Yes.
premature translation termination.
Yes, that is certainly a possibility. Yes, if that is the case, say we have mRNA and you say there is a stop codon has formed, this is the original stop codon, right? TGG was there, which has, because of single nucleotide polymorphism, you have a stop codon now. Okay, assume this is mRNA. So the normal one would have produced a protein of this big, and the new one is producing protein of, by translation, this part. Is that right, what you meant?
Yes, sir.
Yes. In that case, what would you expect the size of the mRNA? Would you expect the size of the mRNA to be large or small or equal?
So I guess the mRNA size would not get influenced.
Yes. Then we would have expected a band here. Is that right?
Yes, sir.
But now we see a band that is here, which means the mRNA size is smaller, which could be the result of the smaller protein. You agreed?
Yes, sir.
Yeah, I mean, what you said is also certainly a possibility. What I'm trying to say is, as I said, everything is possible. What is the most probable one is our job to justify or to qualify our probability, what we are trying to put it as an answer. So when a question is given, I would want that you show your thinking and trying to connect what is x1, say x2 in through southern blotting. What did we learn? Make different possibilities. Through northern blotting, make different possibilities. Some of the possibilities could be eliminated in this round based on information from northern blotting. And then we have western blotting, which would also provide more clues about narrowing down the uh, probable cause of probable type of mutation that is responsible for the X2 allele. Okay, the scheme or general process should be by thinking on these lines. It's like making a puzzle and trying to come up with the best possible answer. Okay. Any other questions you had? Anybody?
Sir,
Yes, please go ahead.
sir, this is regarding the assignment, sir.
Okay, yeah, tell me.
Sir, for the PPT presentation, for how much time it should be, sir?
At least 10 minutes. I didn't mention that. I would have. I'm expecting 10 minutes presentation. There is noise from.
Okay, sir. Thank you, sir.
Yeah. I actually want 15 minutes, but I think it's the end of the semester. I don't want to bother you. Some people will do it more, and that's always a good thing. I would like that you do more, but minimum at least 12, 15 minutes, sorry, 10 minutes at least. You're in fourth, you would have. This is not the time to bother you, I guess. So I will go with at least 10 minutes. Please show the depth of the work that you are doing. It's important that you're speaking the specific details. Don't speak anything superficial. We don't want anything superficial. When you make your PPT, the first 1 and 2 slides should be the superficial general overview. When you go into the content of what you're doing, please speak highly specific details. This is a kind of training you will have for your project presentations. You're having your mini project presentations to come up. You also will have final projects, and this is how you practice. I'm not going to say what is right in your or what is wrong. It is about you communicating the science that you have worked on very efficiently and confidently. It's about you, it's not the knowledge per se in that. So please try to do as good job as possible. In the same is the case with written assignments. I am looking for, if there are some good quality assignments, we can try to publish it. We can go ahead and try until submitting. Let's see whatever happens. But I should be able to see the efforts in there. That is the important part in the written one. Okay? Is it clear?
Thank you, sir.
Yes.
Yes, sir.
Thank you. Thank you. Okay, then I'll post the videos that I have recorded in last semester for CRISPR-Cas. You can also watch several YouTube videos. Please come prepared. Then you can have questions. Maybe I can learn from you as well. Okay? Then take care and have fun. If there are any questions with CIA marks or anything, please contact me. But I think I have been liberal enough. So just have a look and let me know.